I was watching a rerun of one of my favorite movies on TV when suddenly I got a message. I checked my phone and it was Alan. And Alan was very excited about something that was coming up on a Spring Boot release. It had a funny name, CRaC, and Alan wanted me to test it as soon as possible. But we had to exchange a couple of messages before I agreed to do so. After our message exchange, I was left wondering, what should I do with this and should I try it now? Well, why not? I will try it now. I will try Project CRaC right now and I will use schedulers with my Spring Boot process. Project CRaC, CRaC, Coordinated Restore at Checkpoint. It means also, in other words, that we can create a snapshot of our virtual machine, persist it to our file system, and restore it at a later point in time. The idea is to reduce the startup time of an application. Spring has adopted this in recent versions. This means that Spring 6.1 and Spring Boot 3.2 now offer full support to Project CRaC. In the background, this project uses CREU, which stands for Checkpoint Restore in User Space, which can only be used at the moment in Linux distributions. Luckily, Linux has been my go-to operating system for a long time. I will, however, make containerized versions of my own project on GitHub so that we can run the same tests on other operating systems like Windows or macOS. But I was curious about one particular situation. If we make a freeze of our running Spring Boot application, we know that the application context will be closed, along with any sockets, files, or pools that are left open just before the snapshot gets persisted to the file system. It gives the feeling that we can pause time itself and resume it sometime later. It seems like an easy concept to grasp, but this instantly sparked my curiosity in knowing what would be the behavior of Project CRaC when working with Spring schedulers. You see, Spring schedulers use the system clock as reference to function correctly. But if our application freezes, how would they keep on functioning after the application resumes if they lose the last reference? For that, I have created an example. And in order to be able to run it, let's have a look at 3 important things that you need before starting it. The first thing is that you are able to run the example on a Linux operating system. This could be locally or in a containerized form. Secondly, we need to be able to run the compile jar in a JVM that is compatible with CRaC. I have used the SDK manager for that. And finally, we need a Spring compatible version, and that is now Spring 6.1, which is included in Spring Boot 3.2. Let's have a look at our example. If we go to the root directory and then to demo projects, and then to CRaC service, and then to the sources, we will find the implementation of the entry point of this application. This is a Spring Boot application, and so it needs Spring Boot application as an annotation on the main class, that is CRaC service application, and then on it, I have also annotated it with enable scheduling. This will activate scheduling in our application. In the blocker controller, we can find the implementation of a get endpoint by means of the get mapping annotation and function blocking status, which is only going to return the value of level. Level, it's just an atomic integer that we are going to receive from this get method. At the same time, we have a scheduler, and this scheduler is programmed to run at a fixed rate of every 5 seconds, so 5,000 milliseconds, and it is going to decrement the level, and it will print out the current timestamp, and the value of level. The idea is that we're going to see in the logs the value of level changing every 5 seconds. So let's build our application. Now that we have our application built, we can now run it using java-jar, build, libs, and then our application, which is CRaC service snapshot.jar. And now the application is running, and we can see already that the first printout is 9 with the current timestamp. Then 5 seconds later, we've got 8, 5 seconds later, 7, and so on. But we started the application with the default commands, so this application is not ready to be frozen. So the only thing we can do effectively is just to stop it. At the moment, our configuration only matches 2 of the requirements that we mentioned before. So this is a Linux system, and we are running Spring Boot with the right version, 3.2 and Spring 6.1. However, we are still missing the JDK. Let's check which JDK are we running right now. If I do a Java version, then I get version 21, but if we look closely, this is OpenJDK version 21. What we want is a CRaC version of the Java JDK. For that, I have already created a script, an alias for it, and that I call JDK21 CRaC. What the JDK21 CRaC alias does is simply using the SDK manager and switching my Java version to this one, 21.0.1 CRaC Zulu. If we check on the Java versions available in what I have on my machine installed, we can see that the version that I am using is this one, 21.01.1 CRaC Zulu. In the description, you can find more information, and even in the project itself, about how to install the SDK manager. It is very useful, and for me, it made it very easy to make this alias and to have the JDK readily available for us. We now need to run the right command. Let's have a look at which command is that in the make file that I've made available in the project. So this is the make file, and here we have different scripts, and the script we are interested right now is this one. Start service CRaC, and then here I have a setup just to set up the SDK manager environment. Then I'm just asking which version am I using, which now should be this 21.01 CRaC Zulu. And then I'm doing the actual configuration to make sure that the Java virtual machine is started with the CRaC capabilities. That is done via this java-xx CRaC checkpoint 2 and the directory where we are going to save our checkpoint. This is how we persist the Java virtual machine that we are running. And then, of course, just the default commands, -jar, and then the jar that we want to run. If we use the make file, though, to start these scripts, this doesn't always work. So the best thing to do is to just copy what we have here and run it directly from our command line. So if I do that, we start our application immediately. Now, it is very important for the next step that we focus on where the scheduler is at. Now it's at 8 approximately. And now in another tab, we're going to first check which version are we using. So this is not the CRaC version. We just do 21 CRaC. This is my alias. And then what we want to do is to freeze our application. To freeze it, we use this J command followed by the jar. Then finally, this extra switch will tell the application to close the application contacts, pools, sockets, and possible files that have been opened. and persist the Java virtual machine to the directory we've configured before when we started the application. So let's run just that. But before I run this command, let's go back to our previous tab and see exactly where the scheduler is at the moment. And then immediately stop it. It's on -11. And now let's stop it. We get a response. We get this number, and we get checkpoint ... And then if we go back to the previous tab, we see that the process has been killed and the application has stopped. Now everything is persisted. Let's have a look at the temporary directory where our Java virtual machine is currently persisted. Inside this directory, we of course don't need to know how this works, but it's just for reference. There are all of these image files and also a log file. Let's now start the application from where we've left. And another thing that I want to point out is here somewhere we know exactly how long the application took to start. The application has started in roughly half a second. Now the whole idea with this process is that as we resume the application, it will start out much faster. So let's do just that. In order to do that, we will have to run this command, which essentially only means that using this command -xx CRaC restore from, we're only just saying to Java, start this virtual machine that has been persisted on this directory. So let's do that. And remember, we froze the execution of our application when our application was busy on level -11. Let's start it. Here's the odd thing. The application started very quickly. It restored in 116 milliseconds, which is extremely good for a start of an application. Obviously, because this is a restore from a frozen point in time where the application has already performed operations that it needs to do upon startup. But the other thing is that if you notice very closely, it immediately ran everything that it was supposed to run in the middle of the execution. So from the moment we froze the application to the moment we started the application, all of these level decrementations were supposed to have occurred. However, when we restored our application, every single execution of scheduled fixed rate tasks that were supposed to have occurred during that period has occurred instantly. So it's almost like for one single moment, one singularity, everything happened at the same time. All of these from -12 to -35 was launched immediately at the same time. And we can see that through the timestamps. But let's go back to what is the focus of Project CRaC on Spring. Essentially, startup times. We want to start our application as fast as possible with a performance improvement, in this case, even better than native. This is a great technology. But what I have found in the schedulers is actually the reason why I made this video. I think it's very important for us to be aware of corner cases. And this is one of them. This is something that I didn't saw coming, and it happened right off the bat. Just the first time I wanted to test Project CRaC, I decided to use schedulers, and immediately I ran into this situation. It could be that everything that is timed within a Spring Boot application with CRaC capabilities will occur anyways, instantly, when the application starts. And this is something that we need to be aware. If you are using Project CRaC, make sure that you are aware of this and that you see if it actually happens to you or not. I don't know and I have no idea why this happens. I really would love to know. And for that, you can use the comment section to please let me know, or at least discuss the topic, so that we can figure out what is happening here to Project CRaC, which is very interesting behavior from the scheduler's point of view. This has been my demo on Spring CRaC support. If you enjoyed this video, please give it a big thumbs up, smash that subscribe button, and leave a comment in the comment section. And if you are interested in performance and want to know more about generating native from Java source code, you might be interested in a video I made about Gradle VM purely using the command line that you can watch following the link right over here. As a short disclaimer, I'd like to mention that I'm not associated or affiliated with any of the brands eventually shown, displayed, or mentioned in this video.